Hello, everyone. Welcome to the reInvent 2020 session, STG 313, Reduce Total Cost of Ownership, TCO, for your Linux file-based applications. I'm your host, Sudhakar Mungamori. I'm a Principal Storage Solutions Architect at AWS, based out of San Jose, California. Managing on-premises legacy NFS storage arrays brings complexity and high sunk costs. In this session, you will learn about the latest features of Amazon EFS to optimize costs with your Linux file-based applications running on AWS. We will also discuss cost-saving scenarios for files accessed less frequently. Let's take a look at the agenda, what we are going to cover today. First, we will review the challenges with legacy NFS storage. Here, I will share what our thousands of customers have shared with us. And I will do a refresh of overview of Amazon Elastic File System or Amazon EFS. And then we will go into the total cost of ownership of Amazon EFS based on the feedback that some of our customers gave. And I will walk through a few customer examples. After that, we will see how to reduce your workload TCO on Amazon EFS, relevant strategies for this session. And I will talk about Amazon EFS cost management tools like Cost Explorer and AWS budgets. And finally, we will wrap up with a summary. Let's go. What are the challenges with legacy NFS storage? I categorize legacy NFS storage in two buckets for this session. Number one, for on-premises data centers, and number two, for do-it-yourself, or also known as self-managed cloud in AWS. Let's address on-premises data centers first. For on-premises data centers, you have to acquire hardware, and it will take time. Sometimes the lead times could be about 30 days to 90 days or beyond 180 days. And it will take resources to deploy, carve up the storage arrays, and manage with all the automation that you have built around it. And on top of that, you have to work closely with your facilities and contracts team to make sure that from the time you place an order for the storage array, you have to have the place, power, pipe, and ping all associated building facilities to enable the onboarding process. So that's a long drawn process. In addition to that, you have to manage the capacity management, provisioning automation, and how to scale up and scale down depending on the variable workload from various business applications of your side. And then you have to design an additional backup and disaster recovery mechanism. Let's examine if you are building your own do-it-yourself or self-managed NFS-based systems on AWS Cloud. So I've worked with many customers before EFS on how to build it on top of Amazon EBS or Elastic Block Store. Various reasons, some customers would like to go that route, but still we are contrasting here the difficulties and the challenges of doing it on your own or self-managed build-outs. It requires close monitoring and capacity management. You have to build in multiple disaster recovery availability zones / regions, and you need to have a higher TCO relative to fully managed Amazon EFS. And on top of that, this doesn't include any of the patch management, security compliance, upgrade, and management to meet your business requirements based on your security and compliance guidance. Let's look at what is Amazon EFS and how does it help here. Amazon EFS is a fully managed network file system. It is shared storage and it is serverless file system that is cloud native, highly reliable, and cost optimized. Let's dig into each of these aspects a little bit deeper. Cloud native. So it's simple, elastic, and scalable, and it integrates with most, if not all, of the compute platforms on AWS, like, for example, ECS, Elastic Container Service, EKS, Elastic Kubernetes Service, SageMaker, and EC2, of course, etc. It's highly reliable in that delivers you 4 nines of SLA, cost optimized. So there is no provisioning cost, there is no commitments for upfront uh, build outs. And then you build a lifecycle management, you leverage lifecycle management within intrinsically built into Amazon EFS to optimize your costs. What are some of the Amazon EFS use cases? Before use cases, let us go deeper into each of these intrinsic features of Amazon Elastic File System. It's, as you see, it's a simple. You can get it up and running in just a few seconds in as little as a few clicks. And you can have petabyte scale file system at your disposal for all your applications in AWS. It's easy to use through API, through EFS console, as well as through your management integrations, through, for example, CloudFormation. EFS is elastic, meaning it automatically scales up or down based on your requirements as you add and remove files. And you pay only for what you use. And you also have an additional provisioning throughput. Like, for example, if you require more throughput than the data stored in the standard storage, you can elastically change the provision throughput. It's highly available and durable. EFS is designed to be highly available, and we offer 4 nines of availability SLA, and it is designed for 11 nines of data durability in 3 availability zones. To achieve this durability, what we do is once the data comes in, we write it across multiple availability zones for you. This is all built into Amazon EFS by default. And serverless shared storage. Let's talk about that. EFS, you do not need to deploy any EC2 instances to build Amazon EFS. EFS is serverless. And as your workload scales up, as we discussed before, so does your file system, automatically accommodating any additional storage or connection capacity. Its shared access feature lets you thousands of concurrent access from various compute platforms, as we discussed before, be it EC2 platform, or be it a Lambda serverless platform, or one of the container platforms that we discussed before, ECS or EKS. On the performance side, EFS file system provides low consistent latencies of the order of single-digit millisecond range, and can scale up to tens of gigabytes per second throughput and support over 500,000 IOPS. Lifecycle based cost optimization, we will dig deeper as we progress, but here it is worth mentioning that there are different storage classes, standard storage class and infrequently accessed storage class for EFS, such that you can leverage and reduce your total cost of serving your business applications on Amazon EFS. What are the use cases for Amazon EFS? How are our customers are using those? As I mentioned earlier, EFS is meant to serve the vast majority of file-based workloads, including high-performance workloads. On the left side, you see home directories, container applications, and some of the build and release systems, engineering systems applications like Jenkins, Jira, Git, etc. And some of the enterprise applications, you do lift and shift content management systems and then database backups for your different workloads. On the other side of the spectrum, you can run high throughput required multimedia workloads and analytics workloads in parallel. So we have covered what is an Amazon EFS, an overview, and we have just discussed briefly what are some of the challenges that our customers told us about managing on-premises NFS workloads, or also building out some of the do-it-yourself or self-managed workloads on Amazon EFS. Now let's look at a simple model of the total cost of ownership of doing it in both ways. So let's take the example that you are building out a 0.5 terabyte, 500 gigabyte data set on a Linux workload for network attached storage with NFS protocol. So as Amazon EFS provides you standard storage class, you can have 100 gigabyte, and then infrequent access storage class about 400 gigabyte. This is based on our customers' data. Thousands of customers have told us that 80% of the data stores resides in the infrequent access data store. And then you can also add data protection because AWS Amazon EFS integrates tightly with AWS Backup. You can have backup policies based on tags or based on resource IDs such that you can protect your data set. So adding that, it takes about $53 per month for half terabyte data set running on Amazon EFS. Let's contrast with self-managed NFS environment. I have helped lots of customers before as they required for their business requirements on building out based on Amazon EBS volumes such that they can deploy software on top of that and run their network attached file storage. So let's see here, even if you use reserved instances, say for example, for compute in two different availability zones for high availability, and then you carve out EBS volumes in a fashion that your hot data or active data set runs on GP2 volumes and your infrequent access data can run on SC1 volumes. Based on the math, and there is an additional cost of managing the inter-data transfer costs, inter-AZ data transfer costs. Combining all of these, it's about $444 per month. So what does this tell you? So for this example data set of about half terabyte, it's Amazon EFS is nearly about 90% less than self-managed NFS solution. This math exactly, specifically to be precise, it's about 88% less. Depending on the more you use and the scale of economies, you can leverage the full feature benefits of Amazon EFS. So let's examine how some of our customers are using Amazon EFS, and I will give you two examples that relate to the theme of this session, which is reducing your total cost of ownership, or TCO. Thanks to T-Mobile for being a reference customer, and let's examine closely how T-Mobile has realized up to 70% in cost savings migrating on-premises to Amazon EFS. The challenge T-Mobile told us was the IT infrastructure. There is a new initiative called Customer Experience Improvement Initiative, and they have to migrate their on-premises NFS-based workloads to equivalent network-attached storage for their Linux workloads. So they were previously using open source solutions, and then they tried configuring self-managed solutions on top of EC2. But moving to AWS, Amazon EFS, with a fully managed cloud-native solution, they were able to achieve up to 70% in savings because all the undifferentiated heavy lifting is removed from maintaining and managing the self-managed network-attached storage NFS file solution on AWS. What are the benefits? EFS does not require changing existing applications or tools. So you are using a file system entry point. You can point the same file system entry point using Amazon EFS. Within AWS, T-Mobile can address their storage needs dynamically. And on demand, they can provide applications and their business owners petabyte scale storage as they scale on Amazon EFS. By leveraging the scalability of on-demand storage provisioning, T-Mobile has reduced its execution time to roughly about up to 15%. Let's go to the next example of SiriusXM. It's a satellite radio provider. Thanks again to Sirius for being a reference customer. So let's examine how they were able to reduce the TCO with Amazon EFS. And this also added the time to market and the time to value because they were supposed to go live with a new project initiative, and their estimates told that it takes about 60 to 90 days to build up an NFS solution, self-managed NFS solution on top of AWS. Instead, Amazon EFS provided all the required features and services for their workload to be run on Amazon EFS. EFS, as the customer quotation says, it's like a simple, easy, one-click button on Amazon EFS. So now we have seen customer examples of how some of the customers were using Amazon EFS, and we have covered refresher of the EFS main features, core features relevant for this session. Now let's see how these customers and you as a customer can implement lower TCO on EFS. Number one, EFS is highly integrated with multiple AWS services. These include, as we said, discussed before, the container services, Amazon EKS and Amazon ECS, and so services like SageMaker and Fargate and AWS Lambda. What does this mean? So this maximizes time to value for your applications running on any compute platform of your choice. When you are modernizing your application workloads, you don't need to worry about how should I provide a file storage to that specific application. Do I need to build out storage silos on AWS? It's not required at all. With the help of Amazon EFS, you can provide storage for same set of applications running on, say, EC2. While you're modernizing, you can attach the same EFS file system to your other modernized application workloads. If you're rapidly moving into, say, for example, into AWS from on-premises and modernizing your applications, EFS will be the storage platform of your choice through the entire journey. So this is our first strategy. Let me summarize. Amazon EFS integrates with multiple AWS compute services. Second one, regional service optimized for multi-AZ access. What do I mean by that? So intrinsic by default, Amazon EFS file system, once it is configured, it provides you that kind of transformational redundancy that you don't need to worry about, hey, AZ unavailability at all. It means that when you write data to Amazon EFS, for example, the data is durably written across multiple availability zones, as shown in this animation. Taking a step further, EFS backups are stored in Amazon S3, which is again protects data at S3 level of durability. So create EFS mount targets in each availability zone. So this is the best practice that I recommend in case you are deploying your applications in a high availability multi-AZ auto-scaling groups. The recommendation here is you have to create an EFS mount targets in each AZ that contains your application to optimize on networking cost and performance. So this is our second cost reduction strategy. Let's move to the third one, policy-based lifecycle management. We briefly discussed about this previously. What does it mean? So 80% of our data sets, your workload data sets, as per our customers' insights, are in the infrequently accessed category. So if you use a combination of, if you enable infrequently accessed data set based on the lifecycle policies of 7 days or 14 days or up to 90 days, then the net cost will be about 8 cents per gigabyte month. This is based on the pricing in the US East 1 region, and assuming 80% of the files are infrequently accessed. And most importantly, you need to protect your data, whether it is running on Amazon EFS in a multi-AZ, but there may be a logical corruption for your data set, or your business policies require that you need to protect your data set based on some compliance requirements. So for that, Amazon EFS is tightly integrated with AWS Backup. And in addition to that, it enables warm and cold storage tiering for Amazon EFS file systems. So this is how you reduce your cost for backing up Amazon EFS, and to restore, it gives you an ability to restore individual files and directories. Let's quickly, next couple minutes, talk about cost management tools. Now you have seen how to reduce your overall TCO. So here I will explain how do you make it visible for you, cost and spend. Cost Explorer. AWS Cost Explorer is your tool to understand your Amazon EFS usage and spend. In addition to using Cost Explorer, I also recommend that you create user-defined tagging regimen. If you are not familiar with user-defined tagging or cost allocation tagging, I request you to attend one of the reInvent sessions such that you'll be familiar with those. In addition to Cost Explorer, you can extract the same data to load into your own display or visualization tool through something called Cost and Usage Report or CUR reports. So here I'm showing you an example data set, and you can see how much data is stored in standard storage, how much data is stored in infrequent access storage, and what is the cost and of fetching the data from the infrequent access storage. And you can filter it by cost allocation tag at every file system level. So that's the power of the AWS Cost Explorer. You can go as granular as each file system in a single region. AWS Budgets gives you the ability to set custom budgets based on your EFS cost and usage, both at a high level or at a particular subset of accounts. For this, you must activate your EFS tags as cost allocation tags. Once a tag shows up as filterable dimensions in your budget consoles, you can create a budget for your total cost or a specific file system. Let's wrap up. So we have seen how our customers are reducing their total cost of ownership on Amazon EFS for their business critical workloads. And I've given you an overview of Amazon EFS. And we talked about strategies to lower your workload TCO for Linux file-based applications on Amazon EFS. So what are those? First of all, EFS is a shared storage to build stateful applications across all AWS computing platforms. All is the keyword, whether be it EC2 instances or containerized services or Lambda serverless functions. Next, enable Amazon lifecycle management based on your policy requirements, like 7 days or up to 90 days to transition from standard to infrequent access. Third, to reduce your inter-AZ data transfer costs, you create EFS mount targets in each availability zone. So that's another cost management strategy. And transition EFS backups to cost optimized cold storage tier. And we also covered how to enable cost and usage spend visualization as well as automation through AWS Cost Explorer and CUR reports, cost and usage reports, and AWS budgets. I provided a few links here. These are resources. And the third link is Amazon EFS customer stories. This is most important. And thanks to all those hundreds of customers shared their success stories, such that we can expand the best practices to all around thousands and thousands of customers. Enjoy your journey on reInvent with more EFS sessions. I have listed a few here. If you have not already listened or if you have not already attended those, please bookmark this and then enjoy your rest of the reInvent sessions. Thank you so much. And please don't forget to complete the session survey. Thanks again.